I just wanted to review and add a few new things to the previous video about variables and levels of measurement. This is short, but it's an important video, so let's get started right away. Here are a few rows from a data file showing some student data. We have some demographic information, some educational data, and student exam and final grade scores. The question that I want to answer with this table is the following. What is the level of measurement for each variable, and is the variable measured on a discrete or a continuous scale? I didn't talk about discrete and continuous data in the first video, though it is covered in your text. It's easier to start with continuous data, so let's take a look at that. Continuous variables can be divided into increasingly smaller fractional units. Time, for example, is a continuous variable. While as a practical matter, we might not be able to measure a child's reaction time to some stimulus down to the nanosecond, in principle, with sensitive enough equipment, doing so is at least conceptually possible. Same as something like blood alcohol level. Suppose you wanted to study whether blacks with borderline alcohol levels are more likely to be charged with DWI than whites. Well, you need to measure blood alcohol content, and again, though we might not have instrumentation sensitive enough, measuring down to 100,000th of a percent is at least in principle something that's possible to do. Discrete variables, on the other hand, do have a minimum sized unit of measurement. For example, a household can't have fractional children. You can have one child or 5 children or 20 children, but you can't have half a child. By the same token, a school district can contain 2 schools, or 10 schools, or 100 schools, but it can't have 3.5 schools. That concept of a half school just doesn't make any sense. Income is kind of an interesting one. Income seems as if it might be continuous, since you can have fractions of a dollar, but actually it's discrete. Take a look at your most recent pay stub. Does it contain fractions of a penny? Definitely it doesn't. Going back to the definition, the minimum unit of measurement for salary is 1 cent. Nothing smaller than that is possible, so we say that income is something that's measured on a discrete scale. Just one more thing here. The idea of a continuous or discrete variable only makes sense when we're talking about interval ratio data where we have a real quantity. For ordinal or nominal data, this discrete continuous idea doesn't mean anything. All right, let's get back to that data table now. Here it is, and remember what our question is. What's the level of measurement for each variable, and is it discrete or continuous? Let's start with student ID. Is it nominal, ordinal, or interval ratio? Well, we do see numbers here. But do the numbers represent a quantity? Can we divide a student ID and get a meaningful answer? Is student 001 greater than or less than student 002 in any meaningful sense? Of course not. The numbers are just arbitrary, so this variable would be nominal. How about age? Age is clearly interval ratio and continuous. You can clearly do math with age. For example, I can say I'm twice your age. It's continuous because we can have fractional ages, such as 23.5, or 23 years, 68 days, 5 hours, and 2 minutes. That could be your age. Now, it would never make sense to do this, but you could conceivably calculate someone's age down to a fraction of a nanosecond or smaller. Remember, it's not how the data is actually recorded that determines whether the variable is discrete or continuous, but rather what actually could be measured. All right, let's take a look at gender. I'm sure you can see here that gender is a nominal variable. How about ethnicity? Even though there are numbers in the table, ethnicity is clearly a nominal variable. Most nominal variables are in fact recorded with numbers, as in this example. Each number refers to a different ethnicity, and they're entered into a data file as numbers simply because it's quicker to enter data that way. The numbers here are referred to as codes, and they're explained with a code book that usually accompanies a data file. You may be wondering what this -1 refers to. Datasets often contain missing values, and some way of keeping track of them needs to be established. Some datasets will use large numbers that are clearly outside the range of possibilities for a variable. Others will, for example, 99 wouldn't make sense for ethnic categories. I think the U.S. Census recognizes, I think it's five or six or seven ethnicity categories. Clearly a number like 99 wouldn't make any sense. In this case, we're using a negative number. Now, sometimes there may be multiple missing value codes depending upon the reason that the data is missing. Maybe the interviewer forgot to ask the question. Maybe it wasn't asked to that particular respondent because he or she wasn't qualified to answer. Or maybe the respondent refused to answer the question. All that information will be in a code book, and it's really impossible to work with any data set that doesn't have a code book or if you don't have the accompanying code book. Level here refers to class level, freshman, sophomore, junior, or senior. As in the previous example, these are recorded with numerical codes. Because class level does have a component of amount, a junior has had more schooling than a sophomore, you'd have to call this one ordinal. Clearly it's not interval ratio, since it doesn't make sense to say that a senior is twice a sophomore in any meaningful way. And though the numbers here stand for categories, because these categories contain this notion of amount, ordinal would be the correct answer. Frankly, I probably wouldn't use these categories in a real study. There are low sophomores and high sophomores and rising juniors and all that kind of stuff. And these categories, freshman, sophomore, junior, senior, are just not precise enough for most purposes. For this reason, total number of credits accumulated is a better measure for how far the student has progressed in his or her educational career. All right, how about this one? You probably figured out that number of classes is interval ratio. Student 1004 was enrolled in twice as many classes as student 1007. You can do math on this data, in other words. But is it discrete or continuous? Well, discrete is the right answer. It doesn't make sense to have fractional classes. You can be enrolled in one class or two classes, but not in 1.5 classes, or in 1 2/97 of a class, for example. That just doesn't, it's just not possible. It doesn't make sense. So we'd have to call this one, again, interval ratio, but measured on a discrete scale. How about this one? Well, I'm sure you've guessed that this is interval ratio, but how about whether or not it's continuous or discrete? Well, you might say it's discrete, but remember, some professors give partial credit on an exam. I try to if I can. And though no one would give a grade of, say, 1/100th of a point, such a score is possible. And in a way that, say, half a course isn't possible. Therefore, this one would be interval ratio and continuous. And last but not least, grade is obviously not interval ratio. Question is, though, is it nominal or ordinal? Well, clearly a grade of A indicates for student 1001 did better than student 1002 who got a B-. Even though there are letters and not numbers in the column of data, we do have an element of amount, so you'd have to call grade ordinal. All right, just one more thing to go over. Your text introduces this idea of the cumulative property of levels of measurement. What this is really all about is the idea that you can create an ordinal variable from an interval ratio variable and a nominal variable from an ordinal variable, but you can't transform a variable in the other direction. I like to think of this in terms of information. Interval ratio data, for example, contains a lot of information. With interval ratio data, we get exact quantities. If I know your income, I can determine exactly how much more or less you earn than your neighbor. With ordinal level data, all we can do is get at magnitudes. If I asked you to choose your income category from a list, and I asked your neighbor to do the same thing, I could find out who earns more, but I'd have no way of knowing how much more. With nominal level data, all we know is that one thing is different than another thing. We don't know how much different, but simply that they're different. So it should be obvious that while I can transform interval ratio data into ordinal level data, it's not possible to go in the other direction. It's not possible to transform ordinal level data into interval ratio data. If I know your income, for example, I can place you in an ordinal income category, such as low income, moderate income, or high income. But if I only know what income category you fall into, say I asked you on a survey what category you fall into, and I gave you a range of choices, it would be impossible for me to compute, based on the choice that you made, what your exact income is. You may wonder why a researcher would want to reduce the information presented in an analysis, but there are often compelling reasons to do so. Those reasons, however, are a topic for another day. I hope you found this video useful.